Okay, so we can solve absolute value equations by graphing, and there are a couple of steps that we will use in order to do that. So the first step is that you're going to graph each side of the equation as if it were a function of x. And you'll see how doing this step will be similar to what we did on number 2 and number 3 in today's bell work. Second step in solving absolute value equations by graphing is to find the points of intersection from your graphs on number 1. And then the last is we want to change this to x values. This should say x, and I'll correct that here. We want to use the x values to state the solutions. After you put today's date on this worksheet or your graph paper, and we're going to go over 2 or 3 problems where we're solving the absolute value by graphing. Okay, so you have your absolute value equation. What's step 1, Savannah, in our steps that we just had? Okay, so we've got 2 sides of our equation. We've got the left side and the right side. So we're going to rewrite each of those as a function of x. So I'm going to write f of x equals the absolute value of x plus 2, and then I'm going to write g of x equals 6 for the right side. So I took the left side and wrote it as a function, and then I took the right side and wrote it as a function. And I need to graph each of those functions. So on the absolute value function, the f of x function, I'm going to first state my vertex. And what is the vertex? Addie, what's the vertex of that? -2, 2. And so I'm going to plot that on -2, 2, about there. You can't see that hardly, but there it is. And then I need to find, just like number 2 on our bell work, we need to find a second point. So I'm going to let x equal 0 and evaluate in that absolute value. So 0 plus 2 is 2. The absolute value of 2 is 2. Plus 2 is 4. So I get the point 0, 4. I will plot that. And remember that we have this imaginary dotted line, but I'm going to not make it imaginary. And I'm going to draw it. It's the axis that our vertex is on, and that we can reflect any point on one side or the other of it to the other side. So I've got that point 0, 4. I'm going to reflect it over that, so that's going to give me that point, -4, 4. And now I can draw the absolute value function. So that is f of x equals, that's this function right here. Now we're going to graph the second function, g of x equals 6. Any thoughts on how that's going to look? What is that going to be like? Well, if we did a t-chart for this, it doesn't matter what we plugged in for x, we're always going to get what value for y? 6. So if I use -1, I'd get 6. If I use 0, I'd get 6. If I use 2 for x, I would always get 6. Your y value is always 6. Remember g of x, that we can just change to y, so y always equals 6. So I'm going to plot those points, and it's going to end up to be a horizontal line where y equals 6. 1, 2, 3, 4, 5, 6. So I'm going to go 6 on my y-axis, and then I'm going to draw a horizontal line. And that's the g of x function. Okay, so that was step 1, where we graphed each side of the equation as a function of x. Step 2 is we're going to find our points of intersection. So if you notice, there's a point of intersection and there's a point of intersection of those two graphs. And from those points of intersection, we want to identify the x coordinates. So on the left, what is that x coordinate right there? -6. On the right, what is that x coordinate? 2. Okay, so our solution is going to be, which I'm going to write, move this up just, whoops, I don't want to do that. Our solution, I'm going to put it right down here, is x equals -6 or 2. Sorry, that's running into that. We use the x coordinates of these 2 points of intersection. And if we did this algebraically, we'd get the same thing. Okay, are we good to move on to the next one? Okay, Jasmine, what's our first step? So we're going to make f of x equal to the absolute value of x minus 4 plus 2. And then we're going to have g of x equals 4. What's our vertex on this absolute value? Bree, what's the vertex? 4, 2. So we're going to plot a point at 4, 2. And then we need to find another point. So what do you recommend we use for x, Reno? What do you want to use for x? 0? Yep, works for me. So, whoops, well, we'll do that. Our other point is going to be 0. When we plug in 0 for x, we get -4 in the absolute value. But then the absolute value makes it a +4. Plus 2 would be 6. So let's plot the point 0, 6. And remember, I've got this imaginary horizontal line that goes through my vertex. And I can just flip that point that I just found, 0, 6, over that axis of symmetry. And I've got a point there. And now I'm able to graph that absolute value. How do I graph g of x equals 4? If I do a t-chart, what's my y? Every y is going to equal what value? 4. So I can use whatever I want for x. I'm always going to get 4. Wait a minute. Yeah. There we go. -2, 5. All going to give me 4 for y coordinate. So I'm going to graph that in green. I'm going to go up to 4 on my y-axis and draw a horizontal line there. Hopefully yours is better than what I just drew with my finger. And then the last step is to find where those two graphs intersect. So we've got a point there, and we've got a point there. And then identifying the x coordinates of those 2 points. And they happen to be 2, whoops, I need to write or what's the other one? 6? Is that correct? Jessica, what's the first thing I need to do? Okay, so let's say I'm going to have f of x equals what? And then I'm going to name my other one g of x. What's that one going to equal? Good. Okay. So, Nathan, what's the vertex on this f of x function? U. Okay, so what's inside parentheses with that x? Inside, not inside parentheses, but inside the absolute value, we have x plus 1. That's our horizontal. So it looks like we would go right 1, but it's always the opposite. So instead of being positive 1, it's going to be negative 1 as our x coordinate. And then the y coordinate of our vertex is just that number that's outside of the absolute value on the right, 7. So let's plot the point negative 1, 7. Sort of there. Again, that's my fingertip, so it's going to be, I can't tell for sure where it's going to go. All right, next thing, because we're about running out of time. I need to pick another value for x. So, Mason, another value for x. 0. So I'm going to let x equals 0 and plug it into the function above. So I have 0 plus 1 is 1. The absolute value of that is 1 times 2 is 2 plus 7 is 9. So I have this 0.09. So I'm going to plot that. Yes. I just picked it. Once you have the vertex, that's a great question. So once you have the vertex, Nathan, here's where my vertex is on that line. Remember? So I just want to pick an x value on one side or the other of that line. So 0's on the other side of it. It's an easy number to work with, so that's why we chose 0, probably. Okay. Once we have that 0.09, then we can reflect it over the dotted line, and there's my other point. And boy, my graph is way up here. Am I going to run out of? Oh, we're good. Okay, so then I'm going to graph the g of x equals 9. So I have a t-chart. Any value I use for x, I'm going to get 9 as the y value. So negative 2, 0, 1. Y will always be 9, which is right up here, isn't it? Then I identify my points of intersection. Boom, boom. And then what are those x values? That's my solution. And what is the left x value, Corey? Negative 2. What's the right value? 0. And look at number 1 on our Bell work. That was the same problem done algebraically. And what did we get? The same answers. There we go. Okay, let's put this away. This is for your notes. Let's go to yesterday's assignment. Let's take a look at number 14. I'll do that with you all.